solve now problem number 9. There you go. So let's see. The first three terms of an infinite geometric sequence are this one, and this one. So let me write that down. U1 is equal to m minus 1, U2 equals 6, and U3 equals m plus 8. Okay, these are the first three terms of an infinite geometric sequence. Question A. Write down two expressions for R. Okay, so you should know this, you should understand this. Since these are the first three terms, let me put them in order, like U1, U2, U3. U1 is this, U2 is 6, and U3 is m plus 8. Then, since we're talking about a geometric sequence, then there should be a ratio, right? This number times the ratio should give you 6, and this number times the ratio should give you m plus 8. So that already has the solution inside of this. Write down two expressions for r. Why? Why do I say this? Because m minus 1 times r is going to be equal to 6, and you get that from analyzing this part, right? And also, 6 times r equals m plus 8. So there you go. 6 times r equals m plus 8. So these are your two expressions. Write down two expressions for r. There you have. You see, this is the solution to letter A. Then B, first letter. Find two possible values of m. Okay, how do you do that? You have to solve this system of equations, guys. This system of equations. You're going to have the following. Look, I'm going to isolate r from this one. I'm going to get r equals m plus 8 over 6, right? And I'm going to put this value, which is r, in there. This is what is known as the method of substitution. So m minus 1 times r, which is this much, is equal to 6. Then I'm going to multiply both sides by 6, and you're going to be getting m minus 1 times m plus 8 equals 36 after you multiply both sides of this equation by 6. And then you will get down to a quadratic equation. After you multiply these two binomials, you're going to get m squared, and then you're going to get plus 7m minus 8 equals 36. From this equation, guys, once you solve it, you're gonna be getting two values for m, two possible values for the solution, and those are the solutions that you're gonna be having for this particular question. Okay, and then they tell you, hence, find two possible values of r. Okay, how do you do that? Basically, you're gonna go back to any of these previous equations, right? And since you have two possible values of m, I'm gonna call them m1 and m2, right? These two possible values that I'm erasing, I'm gonna just call them m1 and m2. After you solve this equation, you're gonna be getting these two values. With one of them, you're gonna put it in here or in here, doesn't matter. It's actually simpler in here. You're gonna put it right there, and you're gonna get the corresponding value of r that corresponds to this one. You see? And let's call that r1. And then you do the same for this one. You're gonna introduce this in there, and you're gonna get a corresponding value of r, which we can call r2. So there are two pairs of possible values, m1, r1, those are corresponding, and m2, r2. Okay, and that's how, with this explanation, you can get those two possible values of r. So A done, B done. C, only one of these r values forms a geometric sequence where an infinite sum can be found. Justify your choice of r. Well, I'm going to leave that to you because you know what the requirement should be on r if you want that such a ratio should be part of a geometric sequence which has an infinite sum. I told you that the requirements for r is that it is less than 1 and greater than minus 1. So one of these two r's will be within this range of numbers, and one of them will be outside. Okay, so pick the one that meets this criteria. So there you go, C. And hence, calculate the sum to infinity. Well, you know that, right? It's with this formula, the sum to infinity being equal to u1 over 1 minus r. You know u1 because u1 is equal to this, and you already have m from all of this section, right? And you're going to be replacing that m in here in order to find u1. You're going to put u1 in there, and you're gonna put the corresponding ratio that you selected in the letter in this one, right? Okay, this one is a very I mean, it's complex. It's complex. If you understand this problem well enough, you are on the other side. Okay, you can be rest assured that you have been understanding these ideas. But I need you to do it on your own, guys. Like once you heard me carrying you through all of these processes, do it on your own, completely on your own. If you don't do these things on your own, you're not going to understand how this is working. You need to listen to me and then replay or reenact all the things that I'm telling you. So there you go, guys. That was problem number 9.